Hi, I'm Viktor Eliasson. I'm the CEO of the company Diadrom. We are a software company offering services and products within diagnostic for the automotive industry and other capital-intensive products. Now, over the past few hours, we have been inspired by innovative technologies, tools that hold the potential to elevate and transform our business. As we now reflect on what we have learned, I would say there are three essential questions to consider. 1. Why should we start implementing these ideas? 2. What resources do we have? And is it the really best use of them? And 3. How can we make these initiatives profitable? To explore this question, let us turn our attention to smart innovation and resource allocation. I will be focusing on three core areas: focus, tools, and people. Today, I will frame much of our discussion in the context of software development within the automotive industry. However, I believe these ideas and lessons we will explore are applicable across many industries, because the automotive industry, as the main player in the leveraging all the possibilities of software. But before diving into these areas, I would like to provide some background on the increasing complexity within the automotive industry, particularly on the concept of software-defined vehicle. For a long time, the automotive industry resembled the story of the Tower of Babel. You know, where humanity was scattered around the world by an angry God, all speaking different languages, creating disorder and chaos. Initially, the automotive industry scaled great with mechanical components, but the shift to more electronics led to a very fragmented landscape where everyone used different configuration and so-called languages, leading to disorder, chaos, and inefficiency in development. Then this guy named Elon Musk came around and changed the dynamics in the industry and forced all automakers in the world to go with a centralized computing approach, an electrical vehicle which both were supposed to reduce the complexity in software development and building smarter cars. But it's all about creating a value stream, both a digital and physical, that operates seamlessly with the various layers, abstracting the complexity of the vehicle or the hardware. By structuring these layers, we can streamline development, reduce complexity, and make vehicles smarter and more efficient. In fact, in just 2 weeks, it will be almost 40 years since the term Terminator came out, predicting that Skynet, an artificial general intelligence, and what we're hearing right now in the real world, this AI is about to take over any day now, and the machines are supposed to control us all. But after working with the software-defined vehicle, I can confidently say that we are not there yet. If we are still figuring out how to get all the pieces of a software-defined vehicle to work together without a glitch, I would say the humanity is safe for a while longer. Hopefully. Today's vehicles are not just machines, they are a platform for software. The software-defined vehicle are transforming how we build, adapt, and use vehicles. But this is new complexity. We also need a new way of thinking, and it starts with focus. Being able to focus is the very first step towards managing complexity. and creating sustainable systems for the future, leading to a better, more comfortable, and safer driving experience. So, with all this complexity, the big questions are, should OEMs really be focusing on the middleware, protocols, or internal switches? Do end customers really care if their vehicles run on diagnostic over IP or specific operating system? I would argue no. Customers care about a seamless experience. They want features that make their drive safer, smarter, and more enjoyable. This is where the focus should be. And the OEMs have a unique opportunity to prioritize what truly matters, creating features and applications that enhance the user experience. Just imagine if, instead of getting bogged down by internal protocols, OEMs directed their energy towards innovation at the user level. Instead of focusing on middleware that customers never see, they could actually build applications that connect with the users, transforming the car into more than just a vehicle, more into an essential part of the end consumer's digital lives. Just think about using a smartphone. Most people do not care about their technical specs. They care about what the devices allows them to do. A smartphone succeeds because the experience it provides, not the technology behind it. The same is true for the software-defined vehicle. By focusing on what directly impacts the driver, OEMs can deliver real value. So, now I want you all to think about if you're using your skilled people or money for adding real customer value. When we work with software-defined vehicle, modularization is the key. By building systems in modules, we make vehicles more adaptable and sustainable over time. Each module is an independent component or module that can be developed, updated, and tested without affecting the rest of the system. This approach allows us to respond to new customer needs more quickly and sustainability than ever. We can think of modular components like Lego blocks, where each block represents a part of the vehicle, one for the drivetrain, another one for infotainment, and another one for safety systems. With the Lego parts, we can build a simple model of a vehicle where each block could be added, removed, or replaced independently. Yet they all fit together to form a cohesive whole. This visualization of an electrical control unit helps us demonstrate how modular components work within a vehicle. They can be swapped out, upgraded, or updated individually without disrupting the rest of the system. It's a tangible example how modular designs provide flexibility, enabling us to adapt and evolve with the needs of our customers. Now, to enable fast and efficient software development, software-defined vehicle development, we need the right tools and pipelines. Today, we often see organizations using a mix of off-shelf tools and custom-built solutions. This creates a fragmented tool environment that could be challenging to maintain, especially for 15 years plus. By standardizing our tools and creating a streamlined pipeline, we can not only simplify development, but also quickly iterate on new services and businesses that benefit the entire automotive industry and the vehicle owner. But let us be honest here. And I'm sure many of us have experienced this. In every software project, there is someone like MacGyver, a person who is thrilled to integrate a new open source library, build their own continuous integration pipeline, or develop a new custom tool. Right? Do not get me wrong. I'm all about innovation, but only as much as necessary. Reusing software is a valuable asset, and projects with low reuse leverage, below 30%, are also much likely to suffer from significant schedule slips. With standardized tools, we can ensure that development is consistent and more maintained, while also benefiting from proven solutions. So, shifting left, focusing on requirements and infrastructure in the development process, and focusing on reuse helps us not only reduce technical debt, but also stay on schedule. Tools, therefore, are just not a support system, but a strategic part of our business that saves time and ensures quality. Another question for you all out there. Are you really planning and building infrastructure that supports the strategy to win your customers? In a global world, we often work with teams across multiple locations, and this is also true for the software-defined vehicle and the development of it. However, the more locations involved, the harder it becomes to maintain efficiency, reliability, and safety. This is why we need a clear strategy for resource allocation and collaboration. With unified work processes and effective communication, we can minimize challenges and create coordinated efforts, which is essential when collaborating with distributed teams. Furthermore, fragmenting automotive software development across multiple sites may seem like a smart move to access global talent, but it comes at a cost. As you can see here, productivity takes an immediately hit, dropping by around 11% when just adding a second site. And each additional site brings a further 5% compound loss, plus adding complexity and coordination challenges. The elephant in the room is this. While multi-site development offers advantages, it's also introduced inefficiencies. To succeed, we need strategies that maintain productivity without compromising the benefits of global collaboration. There is also a culture dimension influencing how software development projects are approached. For example, from one of our customers. In China and India, teams may operate within hierarchical structures and emphasize collective success, adapting more readily to change and uncertainty. In Poland, a preference for clear guidelines throughout planning and a competitive edge may shape their software development. And here in Sweden, a focus on individualism, low power distance, and work-life balance may foster a collaborative, flat, and flexible environment. Each culture brings unique strength to software development, which can be leveraged depending on the project needs, but also the organizational. When managing multinational teams, recognizing and respecting these differences helps optimize team performance and create a more inclusive, productive environment. Finally, the last thing I want to pass along is the concept of going from people to content. We need to start measuring the actual value we are adding to the organization and not how many people we are managing. This and only this should be the baseline for budgets and how to measure the success of a delivery or project. So my last question to you all out there, how could you optimize your organization with these insights? So if you want to produce a less complex product, more cost efficient, or speed up the time to market, my recommendation is to focus on customer value, tools that will reduce costs and maintenance as much as possible, and people. Make the most of them. And as you can see, this quote from Freeman Dyson, a good scientist is a person with original ideas. A good engineer is a person who makes a design that works with as few original ideas as possible. There are no prima donnas in engineering. So at Diadrom, we love to share knowledge in these topics we discussed today, and diagnostics, which is our niche, tend to involve every topic we discussed. So please do not be a stranger. Thank you for attention and looking forward to get some feedback. Have a great one.